Your SDK integration works. The host application can call Claude Code and receive a useful result. Then you add a tool, then a hook, then a background worker. Suddenly, the app is not just calling an agent, it is hosting an agent runtime. That is when embedding the agent means embedding the controls as well. This is lesson 15 in Claude Code Production AI Agents. Today, we look at tools, hooks, and subagents from the SDK side, how to implement the primitive stack programmatically without losing governance. In lesson 14, we learned that the SDK embeds the loop. The host application owns flow, state, messages, secrets, logs, and user experience. Now we add the control surface that make that embedded loop production safe. The programmatic primitive stack includes tool registration, hook checkpoints, subagent boundaries, and result contracts. In the CLI, some of these controls may feel like configuration. In the SDK, your application often participates directly in those decisions. The visible artifact is the SDK control plane map. The host runtime owns identity and state. The tool registry defines allowed actions. The hook layer supervises risky moments. Worker runs handle bounded delegation. The audit store records what happened. Use this checklist before treating the workflow as ready. Narrow schema, input validation, scoped permissions, evidence output. These are not decorative boxes. They are the operating questions that decide whether the agent can be trusted outside a demo. Use this checklist before treating the workflow as ready. Name risk, matcher, action, log, test case. These are not decorative boxes. They are the operating questions that decide whether the agent can be trusted outside a demo. Use this checklist before treating the workflow as ready. Task boundary, allowed tools, return schema, verification. These are not decorative boxes. They are the operating questions that decide whether the agent can be trusted outside a demo. Score the design against this rubric: traceable, interruptible, recoverable, auditable, owned. A weak score does not mean the idea is useless. It means the workflow needs stronger boundaries before it becomes production work. A safe SDK tool is boring in the best way. The input is typed. The host validates it before execution. The action is scoped to a narrow permission boundary. The output includes evidence that the next step can inspect. If the tool edits a file, return the path and diff summary. If it calls an API, return the status and identifier. If it fails, return a failure the agent cannot mistake for success. Implement SDK hooks from a named risk, not from a vague desire to be safe. Name the risk, write the matcher. Decide whether the hook blocks, warns, asks for approval, or enriches the trace. Write the log record. Add tests for allowed, denied, and failure cases. This keeps hooks small enough to maintain when the runtime grows. For SDK subagents, the verification contract is everything. Give the worker bounded context and allowed tools. Require a return schema. Make it cite evidence. Then the parent checks the result before merging. The SDK makes spawning workers possible, but verification makes delegation safe. A useful mental model is air traffic control. Planes move quickly, but not randomly. Routes are assigned. Clearance is recorded. Separation is maintained. Incidents can be reconstructed. The goal is not to stop movement. The goal is safe coordination. Registering a safe tool starts with a narrow schema. Avoid broad free text action fields when typed fields are possible. Validate inputs before execution. Scope permissions. Return evidence, not vague success. If the host app owns the tool, the host app owns the failure behavior too. An SDK hook checkpoint should be tied to a named risk. Match the risky action. Pause or block when needed. Explain the decision. Ask for approval if the workflow requires it. record the result. A hook that does not log its own decision is hard to trust later. The SDK subagent pattern also needs a boundary. Give the worker a task, limited context, allow tools, and a return schema. The parent run should verify evidence before merging the result. Subagents inside a custom runtime are still delegation, not magic parallel truth. The common mistake is building a powerful custom runtime with weak supervision. The wrapper looks professional, but it hides tool calls, stores no trace, and has no approval path. That is worse than a transparent CLI workflow because the risk is now harder to see. Let us recap Lesson 15. SDK tools need contracts. SDK hooks need risks, matches, actions, logs, and tests. SDK subagents need task boundaries and verification. The host application must preserve traceability across the whole flow. The lesson learned is this: if you own the runtime, you own the guardrails. The SDK gives you power, but production safety comes from the contracts you implement around that power. Subscribe for Claude Code, Production AI Agents. The companion book is linked in the description. In Lesson 16, we move into sessions, state, and durability, where the agent run actually lives.